Welcome back, class 9th. We have started with chapter number 13, surface areas and volumes. We have done first two exercises which were based on the surface areas of cuboid, cube and cylinder. After that, we are starting with exercise 13.5, which is based on volume of a cuboid and a cube. So before we begin with the exercise, let's write down a note. So we first want to define what volume is. We will be defining volume in two ways, since we are dealing with solid shapes which can be hollow from the inside. So we need to define volume in terms of a solid object which is not hollow and a 3D object which could be hollow. So let's write down. If an object is solid, then it occupies some space, and that space is called its volume. This is first. Second, if an object is hollow, that is, its interior is empty, then the volume of substance that can fill its interior is referred to as its capacity. So the word capacity, occupied space, the volume of substance that can fill the interior, all these terms mean one and the same thing, that is volume. An example to describe these two statements would be, if an object is solid, consider a brick of butter. So that brick of butter is solid and the volume of the butter will tell you how much space that brick will occupy. If we say it in the other words, that means the space occupied by the butter is actually the volume of the butter present in that brick. Second case, when the object is hollow. When the object is hollow, for that you can consider a glass. So considering a glass which is empty, it can be filled with some liquid, and the volume of the liquid will tell you what the capacity of the glass is. So in all such cases, we are dealing with the volume of the solid shape or the 3D object in hand. Let us write down the formula that we'll be using for the exercise. So first of all, we have volume of a cuboid, provided its three coterminous edges are L, B and H. So its three coterminous dimensions have been represented by L, B and H. So if I quickly draw a rough figure, so let's take one of the vertices. There are three dimensions emerging. One is horizontal, one is vertical, and this one is oblique, slanting. So this is the length, this is the breadth, and this is the height. So if we represent the dimensions by L, B and H, the volume is given by the product of these three. You can simply write as LBH. And for a cube, the volume is given by the measurement of each of its edges. In case of a cube, all 12 edges are equal, and if we represent these edges by A, then the volume will be A into A into A, because length, breadth, height, all three are equal and they have been represented by A. So the product of the three dimensions will be A cube. This is the volume, and the units we use for calculating the volume are cubic units. So whatever units of length or the measurement of dimensions are used, the answer for the volume will be in the cubic units. Now let's begin with the exercise 13.1 on page number 228. Again, we will be changing the order of the questions a little. We will be starting with the easier ones and doing the little complicated ones afterwards. So first question, let's take a look. So this is the first question that we have. A matchbox measures 4 centimeters by 2.5 centimeters by 1.5 centimeters. When the measurements are given in this form, the three values by default are length, breadth and height. What will be the volume of a packet containing 12 such boxes? So a packet contains 12 matchboxes. Each matchbox has the dimensions measuring as given. You have to find out the volume of that packet. So what we will do, we will first of all find out the volume of one matchbox and multiply it with 12. That will give you the volume of 12 matchboxes. Let's write down the answer. If you want, you could write down the length, breadth and the height first. Length is 4 centimeters, the breadth is 2.5 centimeters and the height is 1.5 centimeters. So from here, volume of one matchbox, this is equal to L into B into H. So 4 multiplied by 2.5 multiplied by 1.5. The answer will be in centimeter cube. Now since I do not need the volume of one matchbox, I'm not doing the calculations here. I'm proceeding to the next step. Volume of 12 matchboxes. So the answer obtained will be multiplied by 12. So calculate the answer. This comes out to be 180 centimeter cube. Now let us do question number 2. Question number 2 of the same exercise. Let's take a look at the statement. So question number 2 is, a cuboidal water tank is 6 meters long, 5 meters wide and 4.5 meters deep. How many liters of water can it hold? The measurements of the cuboidal tank are given in meters. You have to find out how many liters of water can it hold. So to find out the volume of water held by the tank, we will find out the product of length, breadth and height. Now the answer that they require is to be calculated in liters. So once we find the volume, our answer would be in meter cube. We will convert it and they have given you a clue. 1 meter cube equals to 1000 liters. So this is what we will be using to convert our answer. Let's solve. The length is 6 meters. The width is 5 meters. The depth is 4.5 meters. So volume of the tank is cuboidal in shape. It will be the product of length, breadth and height. So since these three dimensions are in meters, the volume will be in meter cube and the answer is required in liters, and we've been given that 1 meter cube equals to 1000 liters. So to convert meter cube into liters, we shall be multiplying with 1000. So the answer obtained from here will be multiplied with 1000 and hence the answer will come out to be 1,35,000 liters. So this is the volume of the water that the tank can hold. After this, we are doing question number 3. Let's take a look. Question number 3. A cuboidal vessel is 10 meters long and 8 meters wide. The length and the width of the vessel, which is in the shape of a cuboid, are given. How high must it be made? You need to find out the height to hold 380 cubic meters of liquid. So the volume of the vessel is given, length and width are given. You have to find out the height. So we start this question by making an equation. You've been given length as 10 meters, the breadth as 8 meters, the height of the vessel is missing, but the volume is given. The volume is given as 380 cubic meters. So this means volume, which is obtained by the product of LB and H, the answer for the same is 380. Let's use the values of L and B as given. 10 into 8 into H equals to 380. Solve this equation and obtain the value of H. H comes out to be 380 divided by 80. This will be 4.75 meters. Let's do question number 4. Question number 4. Find the cost of digging a cuboidal pit 8 meters long, 6 meters broad and 3 meters deep at the rate of 30 rupees per cubic meter. So when you dig a pit, earth is taken out, and the cost of digging depends on the volume of earth taken out. So here, if 1 meter cube of earth is taken out, the cost is 30 rupees. You have to find out what will be the cost of digging a pit whose dimensions are as given. So we will find out the volume of the pit, which will actually tell us how much earth is taken out of that pit, and based on that volume we can find out the cost of digging. Let's write down the answer. So length, breadth and height are given. Length is given as 8 meters, width is 6 meters and the depth of the pit is 3 meters. Therefore, the volume of the pit equals to product of L, B and H. This is 8 into 6 into 3 meter cube, because the measurements are in meters. Now cost of digging. Cost of digging 1 meter cube is given as 30 rupees. So cost of digging the pit, the said pit, is given by the volume multiplied with 30. So you can solve the answer. The total cost comes out to be 4,320 rupees. Now let's do question number 5. Question number 5. The capacity of a cuboidal tank is 50,000 liters of water. So capacity of the tank means the volume of the liquid that the tank can hold. This is 50,000 liters. Find the breadth of the tank if the length and the depth are given. So this is just like third question. In third question you were given the length and the width. You had to find out the height. Here you have been given the length and height. You have to find out the width. This will also be done by making an equation. Let's write down the answer. So length, breadth and height are used to find out the volume. Here the length is given as 2.5 meters. The breadth is missing. The depth, which is the height, is 10 meters. So volume will be given by L, B and H. This will be 2.5 multiplied by B multiplied by 10, and the answer for this will be in meter cube because the units are in meters. According to question, the volume is 50,000 liters. These two answers will be equal, but make sure that you convert the units because the volume, which is calculated using the length, breadth and the height, is in meter cube, but the answer given in the question is in liters. Convert one of these. I'm converting liters into meter cube, or you could convert this into liters, any one of the two. We know 1 meter cube is equals to 1000 liters. If you want to convert liters to meter cube, I want to convert liters into meter cube, I'll be dividing by 1000. So this will become 50,000 divided by 1000, and once you divide, the volume will be in meter cube. So this comes out to be 50 meter cube. Therefore, this volume, the one we obtained and the one which is given, will be equal to 2.5 multiplied by b multiplied by 10 should be equal to 50. Solve this and find out the width. This comes out to be 2 meters. After question number 5, we are doing question number 7. Question number 7. A godown measures 40 meters by 25 meters by 1.15 meters. Sorry. A godown measures 40 meters by 25 meters by 15 meters. Find the maximum number of wooden crates, each measuring 1.5 meters by 1.25 meters by 0.5 meters, that can be stored in the godown. So the space occupied by these crates is given by their volume. To find out the number of crates that can be stored in the godown, the space inside the godown will be divided amongst the space occupied by the crates, and the space occupied by anything is measured in terms of its volume. So the volume of the godown, which will tell us how much space is available, divided by volume of one crate, that is space occupied by one crate. Space available divided by space occupied by one crate. So the word space is actually the volume. So volume of the godown divided by volume of one crate. This is like finding the number of tiles again. Let's solve. You could directly write down the final step if you want, or you can do it step by step. So length of godown, width of godown, height of godown, these are given as 40 meters, 25 meters and 15 meters. So the volume of godown, so this is actually the space available. This tells us how much space is available in godown. This will be given by the product of length, breadth and height. This will be 40 into 25 into 15 meter cube. And again, I'm not solving because I'll be using this product as such. Moving on, the second thing I need to find out is the space occupied by one wooden crate. So length of one crate, width of one crate, height of one crate. These are given as 1.5 meters, 1.25 meters and 0.5 meters. Now we can find out the volume of one crate. Product of length, breadth and height. This will be 1.5 multiplied by 1.25 multiplied by 0.5, and again the answer will be in meter cube. Now to find out the number of wooden crates that can be stored in the godown. What we are going to do, we will divide the volume of the godown by volume of one crate. So the volume of the godown was the product of its dimensions, and the volume of one crate is the product of the dimensions of the crate. I avoided my multiplications before. I'll be using these simplified values for calculation. Let us first change these decimal numbers into fractions. So this decimal will be removed. This will be 15 by 10. So 10 actually appears in the numerator. 1.25 will become 125 by 100. The 100 from its denominator will again appear in the numerator. Into 0.5 will be 5 by 10. So 5 by 10 goes in the numerator. Now solve. So this comes out to be 16,000. So the number of crates that can be filled in the godown is 16,000. Now we shall be doing the remaining questions tomorrow.